Hello geometry students. We're now going to start our part of the geometry course where we are working with three-dimensional figures, and we're going to need to learn a bit of vocabulary so we can talk about them. So what we have here is a picture of a Rubik's Cube, and off to the right we have what we call a net. A net is when we take a 3D figure and we flatten it out to a two-dimensional surface. Here, this is a cube, and a cube is made up of 6 square sides, and we can see the 6 squares right here, 1, 2, 3, 4, 5, 6, and we could fold this up and make a cube. Now we have a few more terms that we need to understand. So a face, let's start with a face. A face is a flat surface of your figure. So in this case, we have this Kleenex box. We've got a flat surface up here that is a rectangle. We have another face over here that is a triangle. An edge is like a line or a segment where they meet. So when two faces meet, we get an edge. And all of my edges here are marked in blue. And then a vertex is a corner point where the three edges meet. And I marked all of those corner points right here with these green dots. So these are all vertices. The next terms we need to know is a prism. So a prism is a particular type of three-dimensional figure, and here are the important things to know. A prism has two bases, and those bases are parallel and congruent polygons. So let's look at the bases of each of these. So this one has a base that is a rectangle. It has a rectangle both on the top and the bottom. So we would call this one a rectangular prism. Now our bases are not always on top and bottom. We're looking for two polygons that are congruent to each other. And in this case, I should change color so we can see it. In this case, here we go, we've got this triangle here. And even though the other side is hidden, we know it's there. I'm just going to clone this triangle. Let's see, there it is. And there's another base on the other side there that's hidden from view, which are parallel to each other. So those are the parallel bases, and so we would call this one a triangular prism. And then in this last one over here, the bases again are not on top and bottom, but are actually hexagons. Now you might have said, hey, there's a rectangle here and there's a parallel one below that I can't see, which is true, but all the other faces all have to be rectangles or parallelograms. So if you have a shape that is not a rectangle or parallelogram, it must be your base if it is a prism. So here we have a hexagon on both ends, and so this is what we would call a hexagonal prism or hexagonal prism. Now what you also want to note is that all the other faces are rectangles or parallelograms. So those other faces are these ones around here. I've got a rectangle here and a rectangle here. There's one in the back that I can't see and the one over here that I can't see. On my Kleenex box I have a rectangle here. I have a rectangle on the bottom that's hidden and a rectangle on the side that's hidden. And on this pencil I've got a rectangle sitting on top here and one here, and there are 4 others that are hidden. All right, let's take a little closer look at this. And what I have here is a square prism or a rectangular prism. Now, why do I have 2 different names for it? Well, if I thought of the blue parts as my bases, then it's a square prism because I have a square on top and bottom. But I might say, well, I think the top and bottom are really these rectangles. You would also be right. You could say, well, 2 of these green ones are the bases, and so then it would be a rectangular prism. So both answers are correct. And now what we have over here is our net, and I want to just give you a visual of how you go from the net to the solid. So here we've got an animation of that. All right, we're going to hide that away, and we're going to answer these questions. How many faces, edges, and vertices? Let's start with faces. It is much easier to count the faces on a net than over here. So I'm going to do that over here where I've laid out all the parts. And so I have 1, 2, 3, 4, 5, 6 faces. All right, and it looks like 2 are squares, right? And which are really rectangles, and 4 rectangles. All right, my next question asks how many edges. So now I'm counting all of the line segments. That is not good to do on the net because this segment is the same as that segment. So we're going to do it over here. We're going to keep count of them. So I go around the top, 1, 2, 3, 4. So 1, 2, 3, 4. Then I go around the bottom, 1, 2, 3, 4. So I keep counting. That'd be 5, 6, 7, and 8. And then I have 9, this back one, 10, 11, and this front one, oops, my pen's not working so good. There we go, 12. So we get a total of 12 edges. All right, I'm going to kind of erase that work because it got a little messy, but what you should see to summarize is you've got 4 around the top, 4 around the bottom, and 4 vertical ones for a total of 12. Then for the vertices, we're just going to count all the corners where they meet. So we've got 1, 2, 3, 4, 5, 6, 7, and 8. There we are. All right, let's do another round of that. So here we've got a triangular prism. Now, how do I know it's a triangular prism? Because remember for my prisms, the bases cannot be, I'm sorry, the other sides cannot be triangles. So if you see something that's not a rectangle, it must be the base. And we'll give you kind of a visual on that one unfolding. There it is, unfolding, and we can see those triangle bases. And we're asked how many faces. So for our faces, we're going to count 1, 2, 3, 4, 5 faces. For our edges, oh boy, we can't see them all. So let's try this though. 1, 2, 3. I'm going to draw the back one with dashed lines. That's what we do when we can't see them. So there's another 3, right? 1, 2, 3. So I've got 3 on the one base, 3 on the other base. Then I connect them here with 1, 2, and 3 for a total of 9 edges. Now it's a good thing I drew in these dashed lines because now I can find all of my vertices. 1, 2, 3 around this base, and 1, 2, 3 around that base for a total of 6 vertices. All right, we have one term left, and this is a pyramid. And pyramid, if you're thinking Egyptian pyramids, those are pyramids too. I even kind of drew it in around like this for you. They are named by their base. They have one polygon base. So we would call this one right here a square pyramid because the base is a square. Might look kind of rectangular, but I think that's because of the perspective when we're looking at it. Over here, we have another pyramid, and the base is a triangle, and it really doesn't matter which one I choose to be the base. Let's just say we were thinking that one's the base. So this would be a triangular pyramid. And then here I found a tent, and this tent has a base that actually is a hexagon. So this is a hexagonal pyramid. Now besides having the one base, the other thing that makes something a pyramid is that it meets at a single point called the vertex or the apex. And so you'll see every one of these has that point where everything else meet. And all my other faces are triangles. So right here we would call this the vertex. All right, we're going to do one problem with a pyramid. And so here we have a square pyramid, and there's our net, and we'll just give you a visual of it folding and unfolding. And so you see when it comes down, all the other faces are triangles. All right, and so let's go ahead and count our faces. So when we count our faces, we've got 1, 2, 3, 4. Notice how these are all triangles out here, but my base is a square. So I have 5 faces. For my edges, let's see, I've got 1, oh, I should pick a different color. Let's go with black. Here we go. 1, 2, 3, 4 on the bottom. And then going up to the point, I have 1, 2, 3, and 4 there for a total of 8 edges. And then for my vertices, I just take the points. I've got 1, 2, 3, 4 on the bottom, and 1 on top for a total of 5 vertices.